Okay, so to achieve blending, I first want to look at the build shaders and input layout method, which defines some shader macros, which will then be used to create an opaque pixel shader and an alpha tested pixel shader. This is so we can turn on and off certain functions within the pixel shader. We can get cracking on building the pipeline state objects. So obviously we'll need one for opaque objects. You can't see through them. They get the opaque version of the shader. The blend state is default, which means there will be no blending. For transparent objects, we need to specify a render target blend descriptor, which is where we are going to define how the pixels are going to be blended. We've got regular blend mode enabled, not the logic based one. You can't have both true. Source blend will be blend source alpha. This is the blend factor. So the source pixels will be multiplied by the source pixel alpha component wise. The destination blend is the inverse, so that will be destination pixel times the inverse of the source alpha. Blend up, you just add it on. Now the source blend alpha, you will just take the alpha from the source pixel. You will not get anything from the destination pixel, and then just add it on, so it basically just becomes the source one. Once we've got the render target blend descriptor, you just set it as the blend state render target of the transparent pipeline state object descriptor, and of course just pass it into the creation of the graphics pipeline state. You can call this transparent, which is what we're going to use for all transparent objects. This is where we actually blend the colors between the one already on the back buffer and the source pixel. Of alpha tested objects, once again just get the opaque pipeline state object descriptor, because there is no blending here realistically. It's either the destination pixel or the source pixel. This is based on the alpha channel value. If it's greater than 0.1, then we keep it. If the alpha is less than 0.1, so it leaves room for some error, then we just clip it, don't need it, thank you. So once again, let's look at this. So this is where the clipping happens. We want to do this as soon as possible, so we're not wasting resources on calculating unnecessarily pixels. So when it comes to the fog, there is a linear interpolation between the destination color and the fog color by the fog amount. The fog amount is calculated by getting the distance to the eye from the current pixel and take away the fog start, which is the eye to the fog start. So you get basically this distance, and you divide it by the fog range, which is from fog start to fog end. Once again, if the pixel is outside the fog end, then it's already the fog color. If it's before the fog start, then it's just the original color, and there is no interpolation in this case. If this is closer to the fog end, it's going to be a smaller value, which means it will favor the fog color. If it's closer to the fog start, it will favor the lit color. I will just explain what object goes on what render layer. The terrain is opaque, as you can see. You cannot see through it. That goes on the opaque layer. The water is translucent, so that goes on the transparent render layer. As you can see, the color is blended between the destination pixel of the terrain and the source pixel of the water. The gray is alpha tested. It is either the bars, or which is the source color, or the destination color of whatever's behind it. For this one, back face culling is disabled, so you can see the back face of the little bars. I've also modulated the fog color to demonstrate how that affects what you can see around you. As you can see, I created a separate branch, and it's just a function that changes the color. To achieve a partly opaque, partly translucent effect, unlike the water, which is just translucent, I went ahead and modified the alpha channel of the box texture to include some grey values, in which case they would not be clipped. So I had to push this item back onto the transparent render layer as opposed to the alpha tested one, which achieves this partly opaque, partly translucent green box, which you can see through. As opposed to the alpha clipped one, you cannot see the back faces on here. This is because back face culling is still disabled for this render mode.